We're going to talk about chapter 3.3. The section is called How Derivatives Affect the Shape of a Graph. And I'm going to be doing exercise or question number 11, which says, well, there's three parts. Part A says find the intervals on which f is increasing or decreasing. Part B says find the local max and local min values for f. And C says find the intervals of concavity and the inflection points. So it's going to be a long question, but let's just dive into it. So first of all, we're going to do part A. We want to find where the graph is increasing or decreasing. Well, we all know that when we take the derivative of a function, we're going to get the slope of the function at any point. So it makes sense to take the derivative in this case. So let's do that. So f prime of x is going to be equal to 4x cubed minus 4x, and that's it. And well, now we want to know when the derivative is 0. We want to know when the slope is 0, because those are going to be our critical numbers, our critical points. So we want to know, to find the critical points, we want to know when f prime of x is going to be 0. Well, notice we can just factor a 4x out. So it's going to be x squared minus 1. And we can rewrite this as x plus 1, x minus 1. Because it's the difference between squares. 1 is the same as 1 squared. So we can rewrite it like that. Okay, so therefore, our critical points are going to be x equals 0, x equals negative 1, and x equals 1. That's good. Okay. Now, how do we know when the graph is increasing or decreasing? Well, it's pretty simple. We just plug in numbers at different points in our number line and see when the derivative is going to be positive or negative, and that's going to tell us when it's increasing or decreasing. So what I'm going to do is I'm going to draw a number line. I'm sure you've all seen this a million times. And I'm going to draw in, I'm going to put points in it. I'm going to put the critical points in it. So it's going to be negative 1, 0, and 1. And just so you remember what you're doing, let's just write here that we're evaluating over f prime of x, because that's what we're doing. We're talking about the slope, right? This is kind of awkward. Let me move this around. Okay. So what do we do? Well, we're just going to plug in numbers at different points in the number line and see where the derivative is positive and negative. First of all, we're going to see what happens from negative infinity to negative 1, which is our first part. So let's think about a number that's less than negative 1. Let's just do negative 2. Why not? And we're going to plug it into our f prime of x, this equation right here. We're going to plug it in f prime of x, remember, okay? Because I've made that mistake before. And we see that when we do that, we get negative 24, which is a negative number. So I'm just going to write a little negative sign over here. Now we're going to plug in a number between negative 1 and 0. I'm going to pick negative 0.5 because that's, I don't know. We get 1.5, which is a positive number. I'm going to put a plus sign right there. We're going to keep going. So a number between 0 and 1, I'm going to pick 0.5. And we get negative 1.5. So I'm going to put a negative sign right there. And then finally, a number that's greater than 1, I'm going to pick 2. And if we plug it in, we get 24, which is positive. So I'm going to put a plus sign there. What does this mean? Well, the slope is going to be negative from negative infinity to negative 1. And then it's going to be positive, and then negative, and then positive. Okay, so they're actually asking when is it going to be decreasing or increasing. So let's write it in an interval notation. So it's going to be increasing, I can't write, increasing from, well, we see that this interval right here and this one are going to be increasing. So it's going to be increasing from negative 1 to 0, and then union 1 to infinity, right? And then it's going to be decreasing from, we're going to pick the other intervals, right? It's going to be from negative infinity to negative 1 union 0 to 1. And this is going to be your final answer for part A. Okay, let's move on to part B. So part B is asking about the local max and local min of the values of x. They're basically asking us, looking at this number line and all the work that we've done, where is it going to be a max and a min? Well, if you get a change in increasing, decreasing, or decreasing, increasing, that point is going to be either a local max or local min. If we look at this number line again, we see that the slope here is going to be negative and then it's going to be positive. Here it's going to be positive and then it's going to be negative. And here it's negative and then positive. I always draw those little curves because they help me visualize it. So we can actually see that the local max, without doing more work, right? We just observe the local max is actually going to be at 0. We can see this with our number line. It's going to be at f of 0. It's going to be a local max. We can actually calculate this, right? If we plug in 0 into our original equation, which is x to the 4 minus 2x squared plus 3. If we do that, we see that we get 3, and that's going to be our local max. Notice that for local min, we have 2. We have a negative 1 and 1. We see that those will be local mins. So we do f of negative 1, and if we plug it in into f of x, not f prime of x, don't do that, we get 2, and then f of 1 is gonna be 2. I mean, is it? Yeah, it's 2 again. Okay. So these are gonna be our answers for part B. Those are gonna be our local maxes and local mins. Okay, what about part C? Part C was asking, find the intervals of concavity and the inflection points. Okay, so just when you read concavity, what's the first thing that comes to mind? Taking the second derivative. Second derivative tells us concavity. Basically, we're going to take the derivative of f prime, which is right there. So that's going to be equal to 12x squared minus 4. Okay. So we're going to do something similar to what we did before. Basically, we're just going to equal this to 0 to see when the concavity is 0, and that's going to give us our inflection points. So let's do that. So to find, give me 1 second, okay, to find the inflection points, or the point of inflection, I call them IP, we need to equal the the second derivative to 0. So we get 12x squared minus 4. Notice that we can take a 4 out of it, so we get 3x squared minus 1. And okay, so then we have that the inflection points are going to be either, wait, we have to do more work. Okay, so 3x squared minus 1, can we factor that? Well, let's actually use the, wait, what did I do wrong? Did I do something wrong? Let me check. No, everything's right. Okay. Yeah, never mind. I thought I did something wrong. Okay, so the only way to solve this, okay, so then we get 3x squared minus 1 is going to be equal to 0, right? Let's keep going. 3x squared is going to be equal to 1. Then x squared is going to be equal to 1/3. And finally, x is going to be equal to plus or minus square root of 1/3. So we have two answers, right? X is going to be equal to, we can rewrite this as 1 over square root of 3. And x is going to be equal to negative 1 over square root of 3. Okay, so those are going to be our inflection points right there. Inflection points are, remember, when concavity changes, either from positive or to negative or negative to positive. Okay, so they're asking, well, we already have the inflection point. That was the first part of what they were asking, so we have these two. And they want to know when it's concave up and concave down. So for this, I'm going to do the same as before. I'm going to draw a little number line. And I'm going to put here our inflection points, which is what is going to give us the information. And I like putting the f double prime of x here to remember what I'm plugging it into, right? So we're going to pick a number that's less than negative 1 over square root of 3. Let's say like negative 2, for example. We're going to plug this in into our f double prime, right? And unfortunately I haven't calculated this beforehand, so let me do that really quick. That's going to be equal to 44, which is a positive number. I'm going to put a plus sign right here. Then we're going to pick a number that's between negative 1 over square root of 3 and 1 over square root of 3. I'm going to pick 0. It's easy. So it's going to be 12 times 0 minus 4 is going to be minus 4. So it's going to be a negative. And finally, let's pick 1. Why not? So 12 times 1 squared minus 4. That's going to be 12 minus 4, right? Okay, so that's going to be 8. That's positive. Okay, so we can see here, they're asking when is it going to be concave up and when is it going to be concave down? Well, let's answer that question, right? It's going to be concave up from negative infinity to negative 1 over square root of 3 union, and then from 1 over square root of 3 to infinity. And it's going to be concave down from negative 1 over square root of 3 to 1 over square root of 3. And that's going to be your answer for the third part. And that's it, you're done. And yeah, this is helpful to know how to draw graphs. So that will be probably the next video or in a few videos.